So what I say is getting to space used to be the hard part about the space industry. Now the hard part is building a profitable company. And so the problems have just moved down the value chain. Now, like anybody can raise a seed fund and put a sensor in orbit. What's really hard now is producing already data and reaching the market, reaching customers, and building a profitable, scalable business.
All right, liftoff. The clock has started.
We choose to go to the moon.
Liftoff. We have a liftoff.
Hello and welcome to the New Space Vision podcast, where we feature executives, entrepreneurs and more and talk about their new space vision. I'm Daniel Seidel.
And I'm Sven, and we are the founders of the Earth observation company Slifierz. This podcast was already recorded once, or at least we tried it a couple of weeks back. But the problem is we are right now moving into a new office, and in our old office, for whatever reason, the landlord has decided to provide us shitty internet. So we did something. Daniel, what did we do?
Yeah, basically we ordered Starlink and holy shit, that was a customer experience.
Yeah.
Like we received it a few days after ordering it. We just put in the credit card online. And then once we had the package, we unboxed it. 1 hour later, we had Wi-Fi connected to Starlink's internet from space. So today we are recording the podcast again, and we have Starlink as a backup. So let's see if it works out. And it's pretty cool.
Yeah, it's really incredible. The future is here. But fingers crossed that it works. And today we are very excited to welcome James Slifierz, co-founder and CEO of Skywatch, here with us at the podcast. Skywatch is an Earth observation company, so is Slifierz, and Skywatch aims to democratize access to satellite data and provides its customers with imagery and sellers with a marketplace. Hi, James.
Hey guys, thanks for having me.
Yeah, thanks a lot for being here. Maybe could you just tell the audience what is Skywatch and what is your role within the company?
Certainly. So you described it fairly well. Skywatch is a market-leading distribution platform for Earth observation data. So we have a very strong focus on enabling as many people in the world as possible to easily access Earth observation data, which is essentially from our definition, data that comes from sensors in low Earth orbit. So we currently serve over 800 customers around the world across 25 different markets, 50 different countries, every continent on the planet. And we allow them to easily access data from those spacecraft and utilize that data for whatever problems or business use cases they're solving inside their organization. My job, CEO. So as you guys can appreciate, CEO's job is fairly wide-ranging. I like to think of it as my job is to make sure there's money in the bank, there's a strong strategy and vision in place, and that we're building the right team and the right culture inside of the organization. And then other than that, my job is to pick up any loose ends or any pieces that might fall through those buckets.
Yeah, and I'm really looking forward to the podcast because, I met James just a few weeks ago in Paris. We had not only one evening where we discussed the ecosystem, etc. And what I like about James, what I like about you is you always have also a macroeconomic perspective, which I think is extremely important to understand the ecosystem, the value streams in Earth observation. So I'm really enjoying the discussions. And today we're also going to dive deeper into these topics, right? Not only your product, but also the other companies in this field and like where to position basically a company. Mm-hmm. But before we dive into this one, I would be curious, like someone like you who has always this macroeconomic perspective, what did you do before Skywatch and why did you end up in Earth observation?
Oh, very, very funny story. So I grew up in a machine shop in a very small town here in Canada, about 80,000 people. And my father's machine shop. And we grew up building parts and assembly lines for the food and beverage industry, the automotive industry. And I tried extremely hard to get him to build for aerospace and never really quite had an interest. And then when I went to school, I taught myself how to build software. And at that point, I realized, given NASA's Open Data Initiative that they were launching mid-decade, that I could take some of this data and build interesting applications. I could do what I always wanted to do as a child, which was build a business and build interesting applications in the space industry. And I now had, with my new software development skills, I now had the power to do this. And so what actually started as a side project, which Skywatch started as a side project, using NASA's open data, particularly in the astrophysics domain, to build applications, a very specific application called Skywatch, which allowed astrophysicists around the world to access data from NASA's space observatories in near real time. We built that in 2014, won an award from NASA from the work that we did, and galvanized lots of investor and media interest in what we had done. Essentially, we took a data signal. So, just put this in perspective, there's about a dozen or so space observatories in orbit, 7 of which NASA controls, and the rest of them controlled by other space agencies. And they're looking for gamma ray signals. So like the highest energy signal possible, which usually comes from astrophysical events like black holes, supernovae, magnetars, pulsars, etc. Anything that's like a real high energy event in the universe usually gives off gamma rays. And these spacecraft that are in orbit, they catch these gamma rays, they locate where they are in the universe, and they pass those signals on to an astrophysicist who will do a follow-up observation, either with a ground-based observatory or with a space-based telescope, depending on what they have access to. So before Skywatch, you used to get these notifications in a daily newsletter that you would subscribe to. And what we thought is, how can we build a better user experience for this? How can we enable those signals to get from that spacecraft directly to a researcher in just a matter of seconds? So we built an API. We tapped into one of the downlinked computers, one of the computers that sat at actually NASA Goddard Space Flight Center in Maryland. And we were able to pretty much bring data in as it was getting brought down to the ground in real time into our system. And we were able to do some analysis on where those events, where those energy events are coming from, as well as what they might actually be based on previous energy events and what previous energy signals and what type of astrophysical event they ended up turning into. And so what we did was we built this API that if you were, for an example, a black hole researcher in New Zealand, we would provide you with notifications about potential black holes that are available over your area of research or your observatory during your nightly working hours, because you can only see some of these events, most of these events, in the night sky. And we were able to get that data from a spacecraft to a researcher in 20 to 30 seconds.
Wow.
It's quite incredible. And this was at a time, so think about the year 2014, 2015. This is at a time where the amount of private capital going into commercial space is really starting to pick up. It took a huge leap between 2013 and 2015. And for us, it was interesting because we got an early glimpse at the development or the emergence of the commercial space sector at that time. And I always joke with people that are building companies in Earth observation or in new space generally today that I actually thought I was late to the market in 2014 and 2015, simply because SpaceX they hadn't even landed their first rocket yet, but they were inserting objects into orbit at the time, and we knew there wasn't a business to be built in astrophysics. But what we did notice was that there was this emerging market called Earth observation. And for us, we were naive enough to say, like, this looks exactly like astrophysics, except if you were to turn the telescopes around 180 degrees and point them back at Earth. We should naively be able to solve the same problems and provide the same level of service that we did in astrophysics, but applied to the Earth observation market. And that was sort of what began our endeavors into Earth observation in 2015. Eventually launching EarthCache, which was the market's first API for commercial satellite data in 2016.
Exactly, and super exciting. So I think that explains definitely the name Skywatch, but also that the name EarthCache of your first product, right? First looking out into the sky and now looking back to Earth. What I'm curious about is basically what are your typical end users? Like, who is using Skywatch?
with the actual original Skywatch application?
No, with Earthcache. So today, basically.
Today, yeah. So I would say our early, we kind of look at the market in a few different ways. We splice it up because we're a very horizontal platform in that we serve. We're fairly industry or market agnostic, as well as we do our best to be use case agnostic. We have a really wide variety of customers. So I said at the outset, about more than 800 customers today across 25 different verticals, 50 different countries. The value proposition that we try to solve for, though, the one that we at least espouse to the market, is that a satellite is the fastest and most affordable way to get information about any location on the planet. And so this is the value prop that we try to push into organizations and companies who have never used Earth observation data before. And so if you think about, we can talk about macroeconomics again, or even like macro business strategy. If you're familiar with the concept of red ocean versus blue ocean, red ocean is the currently served competitive market. And the blue ocean is sort of like this green field of opportunity. It is the untapped potential of a given market landscape. And in Earth observation, you can think of the red market as being the sort of like well-served government domain, which has typically been what has made up the Earth observation market in its entirety, going back to the beginning. The blue ocean for us is the opportunities that exist in the commercial market that nobody's even thought of up until this point. And we believe strongly that there's a blue ocean because we believe the Earth observation market will follow a similar growth curve and trajectory to what GPS has done over the last 20 years, which is to say when GPS went commercial in the early 2000s, it was a market that was largely dominated by government players. It was largely dominated by defense, and there was a lot of skepticism that there would even be a commercial market for GPS technology. But early players came in. They built technology that allowed customers in various markets to easily access GPS technology and to incorporate it and to integrate it into their daily workflows or their softwares. And the commercial market took off and obviously eventually eclipsed the GPS market. And that's exactly what we feel is going to happen in Earth observation. So we try to focus on building software and a service that focuses on the blue ocean and not the red ocean of Earth observation. Meaning we're not trying to build a better widget for government and government users. We're trying to build an enabling technology that enables the next generation of applications and businesses to really leverage Earth observation and grow at a very fast rate. So we start with that value proposition. So if a company comes to us from the blue ocean, they've never used, we call them the YEO crowd. They're coming to us, they actually have a well-defined business problem, and they're trying to figure out, why should I use EO? And what we say is, again, EO, it is the fastest way to get information about some location on the planet, if that's your business. And so if you think about somebody needing to monitor remote infrastructure, vegetation, agriculture, natural disasters, they can easily now identify how a satellite, how Earth observation as a technology enables them to better do that rather than sending people there either physically or via other means, whether that's drones or UAVs, etc. So our customer, they do that. They monitor areas of the planet. And we focus very much on a blue ocean customer that needs API access. So they're generally building an application, or they're integrating the API into their existing workflows or some other solution that they might have inside their organization, enabling them to easily utilize this data without much heavy lift at all.
Yeah. So this is really exciting, and we have been at exactly that position when we started live here. We weren't really sure where we should get satellite data from. Or should we use it in the first place? But so you've described how you're solving that problem. Could you just maybe in a couple of sentences just really briefly walk us through what kind of pain customers currently have to experience to get to satellite data? So what's the alternative to using Skywatch?
Yeah, well, so you can describe the early days of looking like this. Imagine taking a government sales strategy and then trying to apply that to commercial markets and hoping that it'll work. that's pretty much what the go-to-market strategy was for space operators up until recently. So very high touch, sales-led, pretty large barriers to entry in terms of costs, usually some sizable minimum contract size. And so before Skywatch, and I'm taking it back a few years, customers generally went directly to satellite operators to access satellite data, or they would work through a reseller network, global reseller network that the satellite operator would have established. That usually those resellers usually looked like some traditional GIS shops that you may be familiar with if you've been either in GIS or in the Earth observation industry. Skywatch introduced the concept in 2016. We introduced the concept of a distribution layer, which really just takes models from other industries. Like, imagine Netflix for television or movies. Imagine Spotify for music. Imagine Twilio for telecom infrastructure. Imagine Stripe for payments processing. We just took a business model from different markets and realized that the same dynamics applied in Earth observation, which is you have a digital good on one side and you have an uneducated market on the other side, but they need to leverage and access that data to unlock value.
Yeah.
And so we introduced the concept of a distribution layer. Now you'll see other companies popping up. We're now no longer the only distribution platform in town. There's other marketplaces coming through. There's even satellite operators that are trying to move downstream and verticalize in order to make this data more available. So there's much more competition in the distribution side of things, which is awesome to see. Because I think the challenge I had as a founder, and I think you guys can appreciate this, in my early days was actually convincing investors that there was going to be a distribution layer.
Yeah.
That it would no longer make sense for there to be a fully verticalized go-to-market option for hundreds of satellite operators. We would just never break open the market that way. So seeing a lot of players come into this industry and realize that how important distribution has become has made my life as a CEO and founder a lot easier when it comes to raising capital and trying to convince people of what this market looks like in the next 10 years or so.
Yeah.
Definitely, and it's exciting. I just yesterday watched like a few episodes of the new series Playlist, which is actually about Spotify. And one interesting thing here was basically, I mean, you just mentioned Spotify, that the biggest blocker was the licensing model.
Mm-hmm.
So basically the traditional industry, and they were also calling them dinosaurs, like in this documentary. And I tell you, like Sven and I, when we wanted to start like analyzing commercial satellite data, it was really, really, really hard to get it from the satellite operators, right? I mean, all these pains, yeah. Then they want upfront payments. They want you just started, you want to build a product, you want to build the product first before you can sell it, right? And you just don't really get this data. And
we really had to pay a couple of €1,000 for the first commercial satellite,
yeah, exactly,
which we could really use.
Yeah,
and both that payment model and the licensing, they're all remnants of how they sold into government, right? They just took that government sales strategy and they tried to apply it to commercial companies like yours.
Exactly. Yeah, and then
licensing included.
Exactly. When you start as a small company, I mean, you start with 0 customers, right? So, and then they want, tell us how much volume you will procure this year. And I have no fucking idea. I'm not the government. I don't know how many square kilometers I will monitor next year. And all these questions, like Sven and I can totally second what you say. And basically, that's why also in the very early days, Reform Life, you already went on Skywatch. And what I really like about your platform is that you just say, for example, high resolution costs that amount of money per square kilometer. Then you have a medium resolution, for example, Planet Earth data costs $2 per square kilometer as a standard, right? And and then basically you get multiple data sets here. But now, before we dive deeper into this one, my question is, like, how do you crack the dinosaurs like licensing model? Like, what is behind this?
Yeah, so Spotify is a really good analogy. I love Spotify for lots of different reasons. Licensing is a big part of it, but the market dynamics are fairly similar. Because when Spotify started their business, there was 5 major music publishers in the world that owned a majority of the world's music publishing content, which you could understand is kind of like similar to what Earth observation, the supply side dynamics in Earth observation were up until recently, although still kind of to this day. It's not like there's not truly good fragmentation yet in Earth observation, though it's coming. But they had to think about how they were able to get this consortium of 5 music publishers on board with their licensing regime and their business model. And the way this works in any aggregation play is you have to convince the suppliers that you truly understand how the market wants to consume the media or the data that they're looking to consume. So Spotify was successful in bringing those music publishing houses on board because Spotify had the data to prove that streaming was exactly how the market was shifting. And they had all the data to show, that they had the growth trajectories to show. And then they also had the competitors to show that consumer demand was moving towards streaming, whether the publishing houses liked it or not.
Yeah.
And then what they had to do is they had to make a decision as to whether they want to participate in that market or not. And it's the same thing's going to happen in Earth observation, which for us, what we spend a lot of time doing is showing satellite operators exactly how their licensing is restrictive to the emerging market.
Yeah.
And then how it's inhibiting growth in the emerging market. And then we work with them to provide better licensing. But I think even more importantly, what we try to do is with the companies that we work with closely that haven't launched their satellites yet or haven't set their licensing terms, we ask them, especially if they're going to be anchor partners of ours and going to market, we ask them if we can write their licensing for them.
Yeah.
If we can provide them with a modern licensing template to serve modern programmatic commercial customers in a way that's not inhibitive or prohibitive of their growth. And so you work slowly, like anything in a market, you work slowly with the incumbents, but we work really quickly with the new entrants coming into the market to make sure that the next generation of satellite operators and satellite constellations have modern distribution policies and licensing frameworks.
Because there I would have a question, because to stick with the analogy with Spotify, right? Spotify built this distribution layer for the music industry, but what they always struggled with was margin, or still are struggling with margins, because in the end they don't own the raw product. So this is why Spotify right now is really going long on providing podcasts or offering podcast solutions to provide their own content. So what's your content strategy?
Yeah, so we have, it's very true. And to build up any aggregator, you really have to, it's really a low margin play until you get to volume. Now, one advantage that we have in our market that Spotify or Netflix, they don't have in their markets, is that their supply content is fairly unique and not replicable, right? So meaning that if I want to listen to Taylor Swift, then there's only one publishing studio that actually controls and distributes and owns rights to that Taylor Swift data. So if you lose Taylor Swift off of your platform, you cannot replace it with another Taylor Swift catalog. There's only one. The difference in Earth observation is nobody owns the rights to a particular type of sensor, right? So you can have healthy competition for, say, very high resolution 30 centimeter data, right? So we can encourage in the market for there to be healthy competition there, which then ultimately serves and for us, we would prefer to serve the operator who provides us with the best price, what ultimately leads us to the best margins. So there's a little bit in our market, just given the commoditized nature of the supply side, there's a lot more leverage to be gained in ensuring that satellite operators are operating on fair terms, but also that there's healthy competition within a certain product category. They're more what we call substitutional goods, meaning that if one provider were to drop out of the market, another provider can come in and provide the exact same service offering that previous provider happened, which again isn't possible with the Netflixes and the Spotifys of the world, given the unique content that they provide access to.
Now this is James end of 2022. Would James in 2012 or 2014 say the same, like that the satellite data is commoditized and you can easily replace others?
I would have predicted that it will drive towards commodity. I wouldn't have said it was commoditized at that time. Nor do I say it's commoditized at this time. because there's just not enough. It's a commodity product naturally, right? Meaning that so my definition of a commodity is that if all of the variables of the products are the same across offerings, the offering that is the best priced will win the market. Meaning that quality variances are negligible. Customers always choose price because it's a commodity input into some output, some program or some application they run in their business that then spits out an output. And businesses are generally incentivized to lower the prices of their inputs as much as possible. And satellite data is just an input into a decision-making process inside of an organization or inside of a company. Yeah. So companies will always choose, when the quality variances are negligible, they'll always choose the lowest priced one. But we're not there yet, right? That there's still varying degrees of quality between offerings, even if it's the same type of data. And so I think what we're seeing with technological advances is us as an industry trying to provide a standard of quality offering across all data products and all data offerings, and then allowing the company that has the best business model, the best cost structure, to provide the best pricing and win the market.
And I think now in 2022, but also in the next years, this is the exciting thing about Earth observation. This is why it changes so fast. Basically, in the past, there was Maxa, there was Airbus, a lot of upfront heavy investments, which were basically paid by the government. Then the past decade, a lot of venture capital has gone into the market. More and more operators come. And I 100% agree with you, right? Like a 50-centimeter multispectral sensor, why not others launch this? Mm-hmm. Now other companies launch it, and some of them are launching it on TerraStream, right? So can you tell us a bit more about your, what is TerraStream and why did you invent this? And how many satellites are launching with TerraStream?
Yeah, great question. So, everything for us starts at the user. It starts at the customer. And one of the biggest challenges of building Earth Cache and maintaining Earth Cache and Earth Cache customers are problems that are introduced from our suppliers, usually having to do with how they process, manage, and distribute their data. They all satellite operators, they historically have built their own ground systems. So that's hardware and software included. And they're all very different. And not to mention, generally, they are not core competencies of their businesses and usually afterthoughts in both development and investment inside of those businesses. Now, if we think about what it means to build a modern Earth observation company, like a modern Earth observation satellite operator, being able to get your data out to market, that's just table stakes moving forward. So every operator in the world is going to need world-class distribution capabilities. That enable them to scale up how many people they can serve and how fast they can serve them at a cost-competitive price point. Now, again, going back to thinking about how markets evolve and the macroeconomics of this, anytime something becomes like table stakes or just standard in going to market in a market, that is an opportunity for a business to come in and to provide that service so that it lowers the operating and CapEx cost of that service to the organizations and the businesses that are in that market. So for example, I always use cloud computing. So it was historically true that to build a technology company, you had to build your own server warehouses, your own data and servers essentially, and build and maintain them. And then what AWS realized, and soon all the big tech companies realized, was that this was a heavy upfront capital costs to these businesses, and that if we could actually remove that upfront CapEx and convert that into an operating cost in a company's business, they could experiment and scale up their businesses much faster than where they have to build these servers and these warehouses themselves. And so we call that undifferentiated heavy lifting, right? And as a CEO, the way you identify undifferentiated heavy lifting is you look at the heavy expenses inside of your business and you think, what of these costs provide us with no competitive advantage? What are the things that we're just spending money on because we have to go to market, but it's not adding any competitive value to our business? That is an undifferentiated heavy lifting, an undifferentiated heavy cost. And soon, that's the building ground stations is going to be an undifferentiated heavy cost. I think AWS and Microsoft have realized this. That's why they're offering their respective ground station services. And soon, just having a platform to distribute your data out to market is going to be an undifferentiated heavy cost of going to market as a satellite operator. So we wanted to get rid of this for satellite operators, for space companies. And so our analogy is Shopify for space companies. 3 core value props. The first one is, first and foremost, so I explained a lot about how we remove costs. I like to think of that as not even being the number one reason why satellite operators choose to use Terrastream and work with us. The reason why, the number one reason why Terrastream customers and partners decide to work with us with Terrastream is because they can access customers and revenue faster than ever before. So it just dramatically accelerates their go-to-market. So imagine how difficult it was for Planet to get to 800 customers. I mean, I think they're just at 855 right now.
Yeah.
Now imagine being able to launch. Imagine being able to launch and access thousands of customers instantly on day one, right? So the primary reason is for them to access customers and revenue faster than ever before. The second reason is that we convert that heavy upfront cost into a variable cost in their business. So I think Planet's another good example of this. I don't think anybody in our industry will ever have to build a Planet again, because Planet had to build what it built because it was first to market. It didn't have the ability to buy and utilize an existing value chain because there was no existing value chain. But if you ask the founding members there what they did, what was the most surprising part about building Planet, it was how much money they had to invest in their data platform, how much CapEx that cost, as well as how much of their operating costs are still that platform today. It's quite shocking, the number. It's as expensive, if not more expensive. I don't think they break this down in their financial statements, but it's pretty close to being as expensive as just operating the satellites themselves. So being able to take away that cost structure from your business is going to give the next generation of satellite companies such a competitive advantage, because they're going to be able to price their products much more cost effectively, because they're not going to have to make up for the cost that they have in holding all of that infrastructure on their own balance sheet. And then third, the third value proposition is just to de-risk any operational or financial risk of building something that's not your core competency. So why try to do something that you're not good at if you can buy it from one of the companies who do this best in the market? So if Skywatch can provide you with a distribution platform that is proven, already serves thousands of customers, why try to take on a financial risk of building it yourself? And this is having major value add in today's economics, within today's economic conditions. And just the macroeconomic conditions of today is one of the primary reasons why we've seen such a huge drive or an acceleration in the number of customers we're talking to on that side of the platform, because companies are now realizing that capital is not cheap anymore, and so they're less willing to spend money to build something that they know they can just buy at a much cheaper cost.
And this, what you just described, like the past minutes, it's extremely what we observe in the market there. You mentioned the heavy costs Planet has. I talked to multiple companies from our network at the past conferences who just launched their first satellites, and I asked them about, hey, are you building your own data platform or not? And most of them still build their own data platform. And I say, no, I really tell them, James, go to Skywatch. Honestly, I really do this. And I tell them, you will fail. Like, it will be too expensive. And one thing is basically just the data logistics to get it right in the cloud, and the API, etc., have the scalable. I mean, Planet was the first company having a scalable API there, and the dinosaurs like Max Airbus, they didn't have this, right? But another thing, which I think will be an undifferentiated heavy lift, is analytical ready data, because even today, Planet, which in my opinion is the most advanced operator regarding their data platform, is not offering SkySats on scale as analytical ready data. They just did with the Planet DAF data, but not with the SkySat data, and they have invested the most compared to others. So I think analytical ready data, and what does it mean for our listeners? Yeah, satellite images, unfortunately, is not like your smartphone camera where you just apply a CNN on. It has a location on Earth where you have shifts of sometimes 300 meters, which come from the satellite sensor. You have clouds in the images, so you need to have multiple acquisitions to get a cloud-free mosaic, and all these things. And this is something where we also at LiveView have to do a lot on our own. Everyone has to do this. And so my question to you would be, how important is also providing analytical ready data on Skywatch? Are you already doing this, or Is this also a piece of the future? And if so, why?
Yeah, so it's definitely much harder to provide that analytical ready data output for some of the incumbent operators where we're getting data from them in a somewhat of a post-processing state, somewhere between like level 1A or 1B, or for listeners who are not familiar with this data, from a somewhat post-process state to getting it to the point where it's analytically ready. And then the amount of work that we have to do is always there's a variance of work that we have to do depending on who the provider is and how we get the data from them. With the providers that are launching on TerraStream specifically, this is something we want to this is going to be native to their distribution. It's going to be analytical ready data. And I think this is, again, it's just important that we get this part of the industry right. And it's the, what I can tell you from my unique perspective on the market is this is the single most overlooked aspect of getting data to the market from any satellite operator that's launching for the first time. All of them completely undervalue and they often overlook how difficult this is and how long it's going to take. And I've seen providers go from thinking that they're going to have analytical ready data like 1 to 2 months post launch to being a year into their operations and still trying to figure out how to get their image processing chain working appropriately. So for us, we're making a ton of investment into making sure that we can I wouldn't say commoditize this, but make this like an out of the box processing chain that works well. And we're going even as far as to build relationships with the sensor developers themselves, so that we know that when somebody launches a particular type of sensor, that it'll work mostly out of the box with our processing solution once that sensor is in orbit and in operations.
So yeah, I want to just make one statement for all the investors which are listening. I am strongly convinced that it's easier to launch a sensor into orbit on a satellite with 50 centimeter today than building a data platform which offers analytical ready data.
Yeah,
totally. So what I say is, getting to space used to be the hard part about the space industry. Now the hard part is building a profitable company. It is now easier to get to space than it is to build a profitable company. And so the problems have just moved down the value chain, right? The problem used to be up the value chain. Now, like anybody can raise a seed fund and put a sensor in orbit. What's really hard now is producing that analytical ready data and reaching the market and reaching customers and building a profitable, scalable business.
Yeah,
that's that's what we offer with TerraStream. That's actually the prop. Like we actually, when we start our pitch, we don't say it's a data platform. We don't say it's going to reduce your cost structure. What we say, it is the highest probability chance that you can have of building a profitable business. So it reduces your cost structure and increases your access to revenue.
Yeah. But we've now talked, I think, like extensively about all the features and capabilities of TerraStream. Can you maybe give some examples of customers which are already using your platform?
Yeah, certainly. So we have, so I'll tell you a little bit about our early focus. So in our initial go-to-market with TerraStream, we pitched it exclusively to what we call new entrants. So these are satellite operators that hadn't launched a satellite yet and or hadn't built any of their downstream infrastructure yet. So full turnkey solution to them. We've announced relationships with Wyvern, with SatRev, with Esper, with a few others. I'm trying to remember all the names to make sure I don't leave anybody out. I know with Modularity Space and with Explore. And one of the core value props, like for us there, is we want to get in as early as possible. We want to get in when you're 6 to 12 months away from launching your first satellite. And some of the things we do is, we provide you with a look at our market intelligence. So we help you see what the demand looks like on our platform for your type of data. We help you figure out like what might be the optimal pricing for your data. We help you figure out what might be the optimal orbits for your data, what markets to serve, all of that. So we try to be as helpful with these organizations as much as possible. But lately, what's been interesting is we've got a lot of inbound demand from logos I can't name, but you can probably, given how small the market is, you can probably identify who they are. We've received just a lot of inbound demand recently from a lot of the incumbent operators who are interested in trying TerraStream for serving the commercial markets specifically. So they're kind of coming to us and they're saying, hey, Skywatch, we need to generate more revenue in our organization. We need to diversify our revenue streams from being just government. Can we partner with you on our go-to-market in the commercial markets? And can we use TerraStream to serve our growing commercial demand? And so we're exploring a few interesting installations of TerraStream here with operators, or it won't be fully exclusive with these operators, obviously, given how large their businesses are and how mature their current operations and infrastructure are. But we're seeing a willingness from many of the current incumbent providers to actually try TerraStream to serve a very specific segment of their market. And so excited to hopefully make some announcements there in the next 6 to 12 months, as well as starting to see how the uptake is from some of those incumbent providers and how it ultimately how it improves how they distribute their data to market.
Yeah, obviously would be curious to see, or would be excited to see, for example, Maxa providing data via your products. That would be excellent.
That would be awesome. We, as Slifierz, I mean, we're using a lot of data sets, but it's like the most challenging business models are always with the dinosaurs. So let's see what may come up in the future, but we are crossing fingers.
Yeah.
Well, I was going to ask our team to clip this out and send it to Maxar, but that was right until you called them dinosaurs, Sven. So I don't know if I can use this anymore.
It was me. So I can re-record this. No, but now everyone has heard it already. It was me. Yeah. So exciting stuff. So maybe to wrap up for the audience, we from Slifierz, we are a customer from Skywatch, and it's really, really important. If you start an Earth observation company, or if you want to scale an Earth observation company, don't underestimate how you get the data. And of course, you want automation. Skywatch is a great tool for this. And I have to say, we are really, really looking forward to all these new upcoming constellations to have to see the commoditization of the space industry right now. It's happening right now. So yeah, super exciting stuff. And honestly, James, great job what you guys have built there in the past. But this is also a transition to our next section, basically, where Sven wants to ask you a question.
Yeah, just very brief, because exactly we already have covered a lot of ground, and it was very interesting. And we have a couple of questions regarding the Earth observation ecosystem, which very few people know as well as you do. So just one question regarding VCs, because you are a venture capital backed company, and in both 2020 as well in 2021, you raised 7.5 million. And then 17 million respectively. How do you think VCs perceive the Earth observation space today in 2022?
It's a very, very interesting question. So a few things. One is what's really true in this market is that the early companies, the early Earth observation companies, Planet, Black Sky, Spire, for some respect, and a few others, they really sucked up the air when it came to VC in Earth observation. Like they really ate a lot of the capital that was in the market. And what ended up happening was a lot of venture capitalists wanted to wait to see how successful those companies would be before investing in the market further. So there was a period after like 2018, 2019, where the amount of venture capital got a little bit cold in the industry. Today, I would say, I don't think you'll ever see another satellite operator raise the levels of capital, particularly in Earth observation, that those companies did. What I would love to see happen in our industry, and we as Skywatch and I personally am trying to help this shift. I want to see the Earth observation satellite operators of the next generation shift to a debt financing model, where they're raising debt because there's a proven demand for the data type they have, and they're raising debt against that to finance the launch of their satellites. Where we struggle in our business is satellite operators trying to raise venture capital and it being the wrong fit for their business, and them taking 6 to 12 months longer to get the financing they need to get to orbit, which pushes the revenue we thought we were going to distribute from their platform 6 to 12 months down the road. And so I'm seeing a real big misfit between satellite operators and their available financing structures. So I'd love to see venture capital get out of the Earth observation satellite space And I'd love to see a debt player come in and say, oh, you're going to launch let's just say you're going to launch a competitor to Maxar. Well, we know that market is, $2.5 billion for 30 centimeter multispectral data. What is your business plan to carve out a share of that, or to expand that, and then to debt finance the launching of that satellite? Because the market is proven it. Again, it's a commodity product. So if you launch the same sensor with the same quality as Maxar, there's a proven market. Like, the market risk isn't there so much as the execution risk is there. But then if you have really good go-to-market partners, right? Like, you're working with AWS Space, you're working with Skywatch, you might even have some good downstream customers who want your data, like LiveEO. The go-to-market risk there is reduced as well, which makes this, I think, a really good
Very interesting.
satellite space for debt financing, right? Because the market risk is less so if you're launching a sensor that's already in orbit, or that already has a proven market demand. And now where we see the venture capital move is more downstream. And I think for companies like ours and companies like yours, specifically in this economic conditions, we are now in a really attractive investment opportunity in Earth observation, because we are the least capital intensive business inside of a very historically capital intensive market. And so for venture capital, that matters a lot. You're just seeing a lot of aversion to capital intensive businesses right now. And I'm seeing that accelerate. I recently asked a well-known space investor if they were doing any space investments right now. And they said, not right now. And I said, okay, can you name me a few firms who are? And they say, everybody we know has stopped, which is scary to hear. But they're still investing in space. They're just looking for the least capital intensive opportunities. So I think as software companies, we're attractive in this market, especially if you're an investor where you've promised your LPs that you're going to invest in the space industry, and you have to put your money in the space market. All of a sudden, the least capital-intensive businesses look attractive, but which also is now driving, and what's incentivizing the satellite operators to not want to build everything themselves. They're like, all right, we think we can get to market. We think we can build a satellite operation without as much capital as we thought we did, because we're going to use AWS Space for our ground station now. We're going to use TerraStream for our distribution platform. And we're maybe going to outsource some of the manufacturing and or integration and assembly of our satellite itself. So we're going to reduce our cost structure in our business.
And our key customer will be LiveEO.
And our key customer will be LiveEO. And I think that's that resistance from venture capital to invest in capital intensive businesses, as they have been doing over the last 2.5 years, is forcing these satellite operators to think in a way that, how do I build a business plan that is not as capital intensive? But also, I just think it's going to move towards being a better fit for debt financing. So I hope we can revisit this in a couple of years and see, if this was right or not. But I personally spend my time talking to debt financiers and getting them to understand the commercial markets for EO, so that we can start to just give, Skywatch would love to just give a satellite operator who's launching a 30 centimeter capability $10 million to get their first satellite into orbit, and then they can pay us back as the transactions are flowing through the platform.
I really like this future.
There's no market risk there. There's no market risk there. We know that there's $10 million of demand.
But I just wanted, like, before Daniel adding another point to it, I just wanted to say, so you're saying that exactly if there's another space company out there who needs money, you don't have to go to VC anymore. You can go to Skywatch in the future, and they provide you with the financing. I think this is a very revolutionary thought process, despite it might still needs a couple of months until it's being ready. I think that just the ideas you're putting out here are really unique, and it's very cool.
I promised you, Sven. I promised. I really love this big perspective. I could talk to James for hours. Yeah.
What we're not too far away from doing is taking the market demand, what we know, and then we'll like in the future we'll have a financing vehicle ourselves, a debt vehicle. We'll see where is there a gap in the market. So where is there maybe unfulfillment? Where are requests not being fulfilled? What data type or sensor type are customers not happy with? Is the price too high? We'll take that information. We will then finance a company to launch something that will fill that gap, and they will pay us back as their data flows through the platform. And that's how we will accelerate the development and the flywheel between the demand and the supply side of it.
Yeah. And I know this. So basically, to wrap it up, there was an overinvestment in hardware versus software in the past, right? That definitely happened. And what Sven and I also have seen is that this understanding or this perspective on the market, which you have just shared, we further need to talk to investors. They need to get deeper into the market. Sven and I have seen in the last round, so you raised 17 million in 2021, we raised 17 million in 2022, so there's a connection. And we have seen already evolvement in the thought process of most investors. So more and more investors have assessed the space ecosystem. However, and this is still the big problem, what we observe, most of them asked us, why don't you have your own satellites? You need to have your own satellites. What is your USP? And holy shit, all these thousands or millions of lines of code, our customer understanding, our software. There is so much more scalability in there, and there are so many USPs. And I think we have to build this future, right, together. And I see also what you have shared. This will change. It will go to downstream. People will see this. And we just need more proof points. And with Slifierz, for example, we have focused on line infrastructure for 4 years right now, just to build the scalable end-user application, right? And so I'm really looking forward to that future, and also shaping this together with you.
But so to stay on this macro level, there are still a couple of questions Daniel and I would love to ask you. So I would have a question regarding price. As we all know, at least theoretically, price is a result of demand and supply. And companies like Slifierz drive up demand, while companies like Planet drive up supply. And obviously, these are trends which are happening alongside one another, but not in tandem, right? One moves quicker than the other and vice versa. How do you think will this play out? What will happen? Will the price for satellite data increase? Will it decrease? Or what are your thoughts?
Okay, so I'm going to show you a screen right now. We'll try to describe it to the audience that's listening. But so I keep a supply and demand chart. It's based off real data that we get from our customer base. So over here, I think you can see my mouse. Yeah, this is what the market looked like recently, like in the last few years. So you have supply that has really outweighed demand, and the current price point sat up around $21 per square kilometer. But where the equilibrium was in the market was really around $11 per square kilometer. Who's buying all of this data at a premium above like what the market actually wants to pay? Well, this is all government right here, right? This is all government willing to pay a premium on the data, and they're keeping the cost of the data fairly high in the market. Now, what happens is as more supply comes online, the supply curve in a supply and demand curve will shift to the right.
Yeah.
Right. And it'll become fairly inelastic. Right. It'll become fairly inelastic because, as we said earlier, if a 50-centimeter multispectral sensor falls out of the sky, it'll easily be replaced with another one. People won't even notice. And that's almost happening already today. But that'll start to happen across almost every data category you can think of. And then what happens? Well, the demand becomes really elastic. And what you see here, and we're looking at a supply and demand curve where the price point is on the y-axis. As the price comes down, the market becomes much larger, dramatically larger. This is based on our own data and our own mapping of what price points are and what applications make economic sense, et cetera, et cetera. But eventually you get to a world where the prices, the average price in the market is multiples less of what it is today. But the number of participants in the market, the number of customers in the market, as well as the number of square kilometers being demanded on an annual basis is going to grow so dramatically that it actually expands the total market probably anywhere from 2 to 5x in terms of overall market size based on what we're predicting it to be right now. So and then notice what happens here. It's so elastic. Why? Because you no longer have government that's willing to pay a premium on this data because their own buying expectations are now going to start to come in line with the commercial market because there's going to be so much supply in the market that they're not going to be forced to have to pay a premium to access a certain satellite operator's data because they maybe control that particular market segment. It'll be truly commoditized, and so you'll see less differentiation and willingness to pay. And so you'll see that really shift the market size and grow it pretty exponentially. So what's key again? Commoditize the supply side. That'll drive prices down, but it'll dramatically open up the purchasing power and the willingness to purchase from customers. And I would just say my last point on this is again exactly what happened in the music industry, right? Spotify told the music publishers, hey, we know you sell your CDs and your albums at $10 to $15 per album. We want to make your whole catalog available to customers for less than that every single month. And the music publishing houses were shocked. They thought this was a good way to just cannibalize their entire market. But what Spotify got right was that there's strong price elasticity in this market, meaning that for every 10% that you reduce the price, you grow the market by 20%. And so now today, even though the price per customer is considerably lower than what it was 10 years ago, the number of customers that are in the market for music is just at unheard of levels, and so is revenue in the music industry. And that's the same thing we need to encourage here in Earth observation. And it's actually fairly similar. For about every 10% we reduce the costs of satellite data on average, we increase the total TAM, the total addressable market, by 15 to 20%. So we grow this pie, the more we can bring the prices down. We should all be encouraged to do that. And to the final point on this, especially to the satellite operators, commoditization is not a bad word. Commoditization is going to build you a massively more valuable business because you're going to be able to reach more customers than you ever thought possible. And so, I think that would be like my last emphasis is like commoditization is not a bad word. Commoditization blows this market open.
Super exciting stuff. So, guys, what happened just right now on the top right? There was a confidential mark on James' slide. So we've just heard something confidential. So we need to see how we can publish this. But
it's a year outdated, so it's good to go.
Okay, let's give it a go.
We will add it to the show notes, and exactly you can find it there.
So super exciting stuff what you have shown, and I mean our listeners which look at this graph will see it. Another aspect what I see here, which will grow the demand maybe even further than with music, is that you mentioned the price for a 50 centimeter sensor will go down, but there's also so much innovation going on the sensor side. So the existing use cases, which you can solve with 50 centimeters, going to be way cheaper because of the new generation and more 50 centimeter solutions. But what also is happening is more 30 centimeter or even 10 centimeter sensors, for example, from Albedo or others, thermal sensors with a higher resolution. This will open up complete new use cases, right? This will happen in parallel. And this is also pretty exciting that these companies will have a way faster go-to-market because they can already use the data platform from Skywatch.
Yeah, and we are absolutely convinced.
I was just going to say I have two things on this, right? So the first thing that we got to do in any new market segment is we need to achieve technical feasibility. So we need to know that the sensor applies to a use case and it solves a use case well, technically. But then usually what there's usually when a new sensor comes to market, there's usually economic infeasibility, meaning that it's only going to be affordable to the top 1% to 3% of the market because it's still going to be early in its life cycle. And then what we have to do is once we know the use cases are established and they're working, we need to drive towards economic feasibility. And we need to focus on bringing the costs of that data down dramatically. So there's technical feasibility, economic feasibility. We're excited about the new sensors because they're going to enable new use cases, but to then really saturate the market with those new use cases, we got to make sure we get economic feasibility, meaning we got to build enough infrastructure where the economies of scale allow the data to be affordable so that most people in the world can leverage it.
Yeah, absolutely agree. And we are here at Slifierz with our business development team always looking for these use cases where we already have the technical feasibility as well as the economical feasibility while you are fighting on breaking the barriers of economical feasibility for other use cases.
Yeah, but this is also a great point Sven mentioned. I mean, you at Skywatch, you see a lot of upcoming Earth observation companies, like satellite providers or new sensors, as well as in the downstream for new applications. So, like two questions. What is the most exciting company with a new sensor? And the second one, what is the most exciting new use case in the downstream industry, which you think will be big in the next 5 years?
Those are really good questions. So I think what's unique about Skywatch is that we probably interface with more satellite operators than any other company in the world. When I look in our Salesforce CRM, we're currently engaged with more than 90 satellite operators.
Wow!
Both those that are in orbit and those that are planning to launch, and about 40 of those on a monthly basis. So I think our tentacles are deep into this industry in terms of our knowledge and who's doing what. And I think that's we have a really unique lens on the market because of that. Now, in terms of what's most exciting on the supply side, the thing that we haven't done well yet in the commercial space, but I think has been proven out decently well from NASA and has been space-based LiDAR. I'm particularly excited about just like any sort of volumetric calculations from space. So I think we're doing a fairly good job. Like we're progressing really well towards being able to understand our world in 2D. And I think like being able to provide, to have the same level of progress and insights and applications, but in a 3D world is super interesting if we can do that from space. Yeah. So we do a few 3D things now, as you know, you can do stereo imaging, things of that sort, but none of that is like really being done at scale or with much accuracy. So I'm just super excited about getting to a point where like we go from this 2D world to a 3D world where we're doing volumetric calculations. Atmospheric monitoring is also going to be very important in the coming decade in tackling climate change. And that sort of that gets to the use cases now. So I think the most important use cases in Earth observation are certainly going to be ones around ones that drive improvements in how we keep our planet healthy, how we keep our climate healthy. And there's many varying degrees of use cases and how we do that. But I also continue to be really excited about the things that are not as big or not as sexy, but they're so it's just so remarkable to me that people are using space for these applications. So for example, we have movie publishing studios, movie production studios that are using satellite imagery now to do location scouting, where in the past they used to send people on planes to these areas to do the location scouting. Now they're using satellites to plan for a location shoot, which is extremely interesting, but also it contributes to improving climate because you don't have to waste carbon on sending dozens of people to a location halfway around the world to scout a location. You can now just use with a few $100s and some satellite imagery and a computer, you can now do the same job. Yeah. And so I think again, what we fundamentally believe here at Skywatch, I think you guys share the same ethos. We invest in space technology to make our planet a better place. That's first and foremost. And so with all of these use cases, I believe in some way we're contributing to either better monitoring the health of our environment or our ecosystem, or reducing the amount of reducing the amount of carbon footprint we're leaving on the planet by making it easier to, scout or look at or monitor all these remote locations.
Yeah, we couldn't agree more, especially with both things you've said. We believe that adding the third dimension to a lot of things.
I always say 4 dimensions because of the time.
Or fourth dimension because of time. But adding this to satellite data brings so much value, as we already analyze a lot of free data stuff. It's interesting that you bring up LiDAR, as we see this popping up now in a lot of spaces. Very excited, but maybe we're also just very deep down the rabbit hole. So that's why we see it everywhere. And obviously use cases in terms of monitoring ESG compliance, climate change, and so forth are obviously and need to be top of mind when it comes to building new solutions and products.
Yeah. So we will do an intro to a Berlin-based company which is doing a LiDAR called Airmo to have the 97th CRM entry for a satellite provider, I think.
Lovely.
Let's do that. But yeah, I think what you said with basically helping to tackle all the challenges we have with our planet Earth, I think that was a good end for the podcast. We really appreciate the time with you. And maybe like the last thing now, what we want to ask you, it's a new thing basically. We would like to know from you who you want us to talk to. It can be very, very open. And we try to get this person on the show.
Okay. You know what you should do? You should talk to your new chief product officer.
Okay.
I think it would. What would be in a really enlightening podcast is to ask him about sort of the transformation of his perspective coming from the supply side now downstream.
Oh yeah.
Why he chose downstream, what he sees the future being, his inside perspective on some of the challenges that satellite operators facing going to market, and why he believes there's large opportunity for downstream businesses.
Nice one. So basically our new CPO is John Atkinson, who was the global lead for partnerships at Planet for more than 3 years. James, you were one of the first hearing from John that he started last week. I'm looking forward to the discussions the four of us will have in the future to shape this ecosystem. So yeah, challenge accepted. I will ask him. He's in the office.
Yeah, exactly. But first of all, thanks a lot, James. That was really insightful. This was really helpful. I think it was a little longer than our typical podcast, but it was worthwhile for sure. We've learned so many new things. I've seen so many new perspectives. And I really have to say, I think you have a unique eye on the market and obviously unique insights as well. So thanks a lot for the last couple of minutes. Thank you, the listeners, to listen in. Please tune in also the next time when we interview guests such as our CPO, but also others. Make sure to listen to our last podcast with Matthias Wachtner from the German BDI, talking about the importance of satellite and space technology for national sovereignty. And please make sure to follow us at New Space Vision everywhere on LinkedIn, Twitter, and so forth. So thanks again, James. Thanks, everyone. Have a great day.
Thanks, guys.
All right, liftoff and the clock is started.
We choose to go to the moon in this decade.
Liftoff. We have a liftoff.